Hi, my name is Julia Silgi, and I'm a data scientist and software engineer at our studio. And today in this screencast, we are going to use a recent Tidy Tuesday data set on Bigfoot reports. Have people seen Bigfoot? Reports of people observing Bigfoot in various places. And we're going to build a model to predict the category, the kind of sighting that people have seen using the text of the report. My goal in doing the screencast is to get to show you how to deploy this kind of model, and specifically how to create a REST API for different kinds of predictions. How it is that you can use the Vetiver package to create the kind of REST API to serve the predictions that you're interested in. So let's go learn something about Bigfoot.
All right, let's get started and build a model for Bigfoot sightings. All right, so I'm going to start by reading in the data here. So if we take a look at what we have here, maybe let's pop it into the viewer. So this is a data set, like I said in the intro, about reports of Bigfoot. And it's pretty interesting data set because we have this free text, like look how long it is. I was northeast of Macy, Nebraska, along the river, blah blah blah. And it goes on, and it has quite long bits of text describing what people with people's experiences that they have with these Bigfoot reports. Information on the location, which you can notice here. Let's scroll down here. So the location sometimes is in a county, state, season, fall, spring, summer, and a title that is here. We could make some mapping if we wanted to do that. A date. Wow, some of these are quite old. And geohash and a class. So let's look at and there's more stuff here. So there are lots of, I think, interesting things that you could do with this, although a lot of it is missing data, right? Like a lot here we don't have the temperature, the phase of the moon. A lot of this is missing data. So we would need to do something about that. What's not missing is that text, and I believe that classification. So let's look at that. So if we have this raw data, let's look at the category class here. So I looked up before I started this what these mean. I'll put the link in the blog post that accompanies this. And so Class C are like secondhand reports that are included in this data set because they're historically important, like things from newspapers and stuff. Class A are what they consider sightings, like confirmed sightings. People saw something and they have a report there. Class B is a report that they think is important and reliable, but that did not involve people seeing anything. So they saw some evidence or had some evidence, but it was not a sighting. They did not see something that they believed to be Bigfoot. So let us change this up a little bit and make this a little more clear. So we're going to take this. I don't want the classification. I don't want the C ones. I'm just going to do binary classification. Let's see. Are any of these NA? No, so there's no NAs in the classification. What about the report? There are some here that just have the location, but this is a very small number. Let's take those out. Let's take those. So not NA for that. And there's quite a bit you could do with this data set, but let's just focus on the that text data, the report that the person gave. I am going to mutate that classification. Let's use case when. So when classification is equal to class A, this is the one, so let's call this a sighting. And we could, just to be more explicit, we'll write it out here. And let's say, I don't know, let's call it a possible, like this is a possible report here. And let's call this Bigfoot, like so. Yeah, let's do it like that. Okay, so what I've done is I've changed the name of what's in the class to things that are sightings and things that are more possible. Let's just do one sort of exploratory kind of bit of work here on that text, just to understand it a little bit before we start building a model. So I'm going to use the tidylow package, which is a package for weighted log odds. And so what we're going to do is we're going to ask the question, what are the highest log odds words that are generated from these two categories? So let's, whoopsie daisy, oops. So let's do this. So let's unnest into the word from that observed variable. So let's count classification word like this. So if I do this, this is I'm going to tokenize, and then this is all the words. So you can see as we tokenize, we have information on time and things like that. So let's that's a lot of words. Let's keep things that have been used at least 100 times, and then we'll use the bind log odds function. So you pipe in the data, and then what you have is the set that you're counting things across, the feature that you're counting, and then n, where are the counts. So let's call it classification, because that's the set across which we are counting things. The feature, the things we are counting, is word. Let's call that. So we can go for this. So these are now these tokens here are numbers, which can be a little confusing. But let's look at the highest log odds weighted, like that. Okay, so let's see, what are the highest log odds words? So these are the words that have the compared to how often we see them in general, they have the highest log odds of coming from these two different categories. So let's notice the things that are sightings. We see things like fur, ape, hands, headlights, witness. So these are the words that have the highest log odds of coming from the things that are sightings. And then the things that are possible, we see things like howl, heard, screams, knocks, listened. So it seems like the sightings are about seeing things. It seems like the other category, the things that are not sightings, are really a lot about hearing things. So let's call this our exploratory data analysis. I could make a plot, I could do more with this, but in the interest of time and getting actually to the deployment of the model, let's jump into it. Okay, so I am going to try to blow through this really quickly. I am going to load the Tidy Models meta package. I am going to split my data into Bigfoot into testing and training. So I'm just going to use these two variables. There's a lot else interesting there that I think we could extend this with, but let's just do a simple or a straightforward text model with just the text, Bigfoot. I mean, you could even combine it with that other text, honestly, which would be very interesting. Okay, so that's the training and testing split. Bigfoot train. We'll take the training data out. The training data out of the split. Let's make the testing set. And then we are going to make some resamples. So here we are going to, let's call it Bigfoot folds. And let's do vfold cross-validation we do this with the training data, Bigfoot train, and we will do stratified as well. Although this is really balanced data, so I don't know if it's going to help me much to stratify in this case because it is already such nicely balanced data. It's interesting. This came from the real world and it's even classes. How often does that happen? Like never. So pretty interesting. In the interest of making training faster and let's just do 5 folds here. So we'll do it 5 times. Okay. So this part is like spending our data budget. We decided what is in training and tests. We decide how to resample. Now it's time for a feature engineering. So this is text data. So I'm going to use the text recipes package. Let's call it Bigfoot recipe like that. And so we're going to declare a recipe. We're going to predict that classification category, class A or B, with the data that is in observed. We're going to pass to the recipe the training data. Maybe it could just be a little bit of the training data just to understand the variable types and names. Okay, so now let's do this. So the first step is to tokenize. So we're going to just do basic, all of this can be iterated on and we do something fancier, but let's do basic tokenization to words. Let's decide how many we're going to keep. Notice here, I filtered out to things that have been used at least 100 times. So this data is very much natural language, people using their vocabularies in an unstructured way. And so what that means is we have a large vocabulary, a lot of words, some of which are not used that many times. So let's say observed, and let's say the max, what is it? Max tokens. Let's do like this, max tokens. Let's try to keep at 2,000. So this is a lot, but often we have to do that when we are dealing with natural language like this. And then let's weight it by TF-IDF. So how compared to the vocabulary overall, how sort of unique is it there? Okay, so we did this. This is our feature engineering recipe. Let me just, I can show you what this would look like. So if we prep it and then we bake it, this is just to show what the output is like, not necessarily that we need to do this right now. And let's do glimpse like that. So now what it's going to do, it's going to tokenize and it is going to keep only the top 2,000, and then it is going to compute TF-IDF for all of these words. So now my variables are these 2,000 words like this. Okay. All right, feature engineering, done. Now, modeling time. So here I am going to use GLMNet or GLIMNet, however you prefer to say it. So I'm going to do a logistic regression model. I'm going to do a lasso model, which is where the mixture is 1. So that means that I am going to be able to use regularization, decide which of these words to keep and which not to keep, which I definitely want to do because the vocabulary is large. So this is often a nice way to start with a text model where you are dealing with natural language. I'm going to tune the penalty because I don't know how much regularization I need. So that's something we have to use tuning to find out. And then let's put these things together. Bigfoot workflow. So I'm going to say a workflow. I'm going to put the recipe that I made and the model spec that I made. So is it ready? It's here. I've done it. Okay, so notice I've got a recipe. I've got logistic regression. Right now the penalty is tunable because I don't know the right value for this for my particular data set. I don't know what to do. So let's do that next. So we are I'm going to use parallel processing. I'm going to set a seed because this is about to use randomness. and let's say Bigfoot result. So I'm going to tune the grid. I'm going to tune the workflow. Bigfoot workflow over the Bigfoot folds. And let's say I'll say 10 like this. So let's see. I hope this doesn't take too long. So I'm trying 10 possible models on 5 different resamples. So I'm fitting 50 models here. Okay, great. That was not too long. I am very happy about that. It is a linear model, so this isn't like super computationally expensive. So I can look and see the results here. So I let tidy models pick this randomly, but looking at this, let me do that one more time because I want to be a little bit smarter about my tuning grid. So when I say grid equals 10, it tries to automatically choose 10 possible values, but let me zoom in here. So this is the penalty, and notice that it's very flat out here. It goes up and then down, which is pretty good shape for pretty good shape for logistic regression, or sorry, for a lasso model, seeing what you there. So instead of letting it choose it automatically, I'm going to say, let me choose. So I'm going to start at 4, 3. Let's start at 10 to the negative third. Let's go up to 1, and let's step through this much. So by this much each time. So here are the values I'm going to try. The different values for penalty I'm going to try. So let me do this. So what I'm doing basically is I'm zooming in to that part where I see the from lower to higher and then the drop, so I can do a better job of finding the value for penalty that will work well for me. So that's about the same number. See, this is nice. This is what I want to see. So I want that I want to pick like a high accuracy, high ROC, and I want to be able to make sure I'm sampling that pretty well. So that worked better. Okay, so how do I get out the right value for the penalty? So there's a couple of helper functions. I can say show best on the result. Result like this. So this tells me first of all, the result looks like this. It's a tibble. It's got the data splits, metrics, any notes of what things went wrong are here. Okay, so if I do show best, it tells me, okay, here is your best value. So it's picking this one, this one right here is the one that it's picking. It's saying that's the best you can do, which, maybe I decide to use that one. I also can try to choose it in a different way. So regularization like this, a Bigfoot result. Sometimes you might want to choose a, I'll say the metric this time versus not letting it choose it automatically. ROCAUC, like that. So that's the same, because one standard error, that might be the best one actually. I meant to do percent loss though. Okay, so the best one, the very best one is this one. But it is saying that the simplest, I could alternatively choose a simpler model here. It's simpler because it has a higher value for the penalty, so more regularization. So basically that's throwing out more of the words, keeping fewer words as the predictor in the model. And it says the best value you have for ROCAUC is this, and you have, if you're willing to live with a 1% loss, then instead I could get this simpler model. So that is what I want to do here. I'm going to choose the simpler model. It's simpler, simpler equals better in almost all cases, so we're going to do that. So I'm going to take my original tunable workflow, and now I'm going to finalize it with this. So if I do that, it will be and no longer do I have tune here, and now I have the penalty that I'm actually going to use. And then I can use this with last fit. So for last fit, what I pass in is the split, the data split. So because that has the training data and the testing data in it. Okay, let's do it. So we're updating the workflow with the final penalty I want to use, and then we are fitting it to the training data, evaluate on the testing data. So this is another tibble, but it has very important stuff in here, like the workflow, predictions, and whatnot. So if I do, let's just blast through this. These metrics are on the testing data, and we can look at this and say, yep, looks about how I want it to compared to what I got from my resampling. And we can also get out predictions, and these are predictions on the testing data like that. And I can, for example, compute a confusion matrix. So what I pass to the confusion matrix is the true value, which was this is the class A, class B, and then the predicted class like that. So here is, whoops, let me make that up. Not so much at the bottom of the screen. So here's like a little text representation of the confusion matrix. That's pretty good. Looks pretty good. Or this is consistent with the the ROC that I had and the accuracy that I had and all that kind of thing. But that helps us understand the differences across the classes. Okay, one more thing that let's just quickly do before I deploy, or we talk about how to deploy the model. Let's look and see what ended up being kept. So let's do variable importance. So I'm going to say Bigfoot final. I'm going to pull out the engine fit like this. So that's pulling out the underlying GlimNet model, and then I can call VI or VIP like this. And so VIP will give me a plot. VI just gives me data. So what it says here, here's the importance. So these top ones are all positive. So it's like muscular, hunched, nose, shaggy, guessing. And these are the negative ones. Whooping, especially, admit, literally. I don't know that. Oh no, wait, some of those are positive too. Negative, whooping, especially, literally. Interesting. So it seems like we've got these words that are more about what something looks like. And then these, I guess, are not about what it looks like, but about the other side. Okay. Great. So this is all just like busting so fast through the model development process. Now let's talk about deploying this model. So the first thing I'm going to do is load the Vetiver package, and I'm going to take that the final object and final object, and I am going to pull out the workflow here. So this is this trained fitted workflow, and then that is what I want to deploy. And so I'm going to create a Vetiver model with it. Vetiver model, and I need to pass it a name. So I'll just call it Bigfoot. That's the name of this model. V. I will save this as an item called V for Vetiver model. So if I print it out, I see some information about it, like what kind of model it is, how many features it has, and so forth. And so, now we would let's talk about we can predict on V. Let's take just a little bit of the test data. Bigfoot test. Let's take like 10. So if I predict on the model, I get a class. I could say type equals prob like that, and that gives me the probabilities of the two classes here. I am going to also show how you can augment this. You can augment this model as well. So you can augment this deployable model. So it's say, hey, for all of the, for here we have, I was sitting here listening to you on something. When I was a young boy, my father would blah, blah, blah. So we've got, these long reports, and then we have the real label and the predicted label, and then these two predicted probabilities. Okay, so if we were going to go through kind of the main steps of deployment, the next thing here would be, the first step would be to version. But let's jump to the second step, which is to deploy, to create a REST API so that we can deploy it. So what I'm going to do is I'm going to say library plumber, like this, library plumber, and then I will say start a plumber router, and then set up my vetiver API here, like this. So and then I will pipe it to PR run, which will actually set it up. So now I've got this here that I can deal with. And so this is the health check endpoint. And here's the predict thing that I can interact with here. So I can put something in here like, I was at our studio conf and I saw a furry, tall creature with scary hands. And if we try this, that is categorized as a sighting because I said I saw something and it was furry. And if instead I would say I was at our studio conf and I heard a terrible roar, but I didn't see anything, like something. If I say something like that, they say this is possible because you didn't say you saw anything, but you heard something. So what this is like, this is how we interact with the model. It tells you we have example curl here that tells us how to interact with it. But this is like interactive documentation with our model for the API that we're setting up. So let's stop this. Like so. And let's say, what if I want to do a different kind of prediction? I don't want that predicted class, but what if I do want those probabilities? You can set up your REST API to give the kind of predictions that are appropriate for you. So if I do this now, and let me put something here. So I'm going to say, when I was at Use R last year, although I think that was remote. Oh, I'll say during Use R last year. During Use R last year, there I saw behind some trees there was a like furry, enormous ape type creature like this, and this will say it will give me the two probabilities. It will say the probability of a sighting is very high, and the probability of the other category, a possible type report, is low. So instead, if I said during USAR last year, I sat quietly in my office and watched wonderful talks. I didn't. There was nothing unusual. So this is kind of an interesting thing to put because I'm not really reporting anything at all. We can see what it does. So it says, you can see it's much less sure than on the last one when we see these probabilities, but it says the probability of a possible report is higher than a true sighting.
All right, so we used regularized regression to predict the category of a Bigfoot report, whether it was like a sighting that someone saw, or more of a report that did not involve actually seeing Bigfoot. Our model was able to pick up on those patterns in a language that people use in those two different situations, and then we showed how to take some steps to deploy that model, how to create a REST API for your model, and specifically how it is that you can specify the kind of predictions that you want to serve. So I hope this was helpful, and I'll see you next time.